In this video, we will be covering the bisection method, which is used to solve nonlinear equations numerically. So first we will consider the linear equations. Let's say these two linear equations. Consider these two equations. So x1 and x2 are independent variable here. So the power of these independent variables are equal to 1, so that the equations are linear equations. Okay. Now if you consider these same linear equations in matrix form, it will look like this. You are having this coefficient matrix and independent variable matrix and the constant matrix. Okay. So now you represent the equation in matrix form, and directly you can solve these matrices to find out what is the solution of these equations. It is the simplest way for linear equations, but this is not possible in case of nonlinear equations, where you are having your independent variable power which is greater than or less than, which is not equal to 1. Then you will be having nonlinear equation. For example, in this case you will be having your independent variables power equal to 2, so it becomes a nonlinear equation. So the power should not be equal to 1. And in other ways, you will be having in your equations you will be having trigonometric function. In that case also the equation becomes nonlinear. Or if you are having a product term in your equation, like two independent variables are having this kind of products, then also this becomes nonlinear equation. So in these cases we need to find an alternative method to solve these equations numerically. So we cannot use the matrix method for these kind of equations where you are having some kind of nonlinearity. Now in this lecture we will be covering equations like f of x equal to 0, and we are focused on a single independent variable equation. So we will be having only one independent variable in our equations. And if you are having two equations, two independent variables and two equations like this, you can easily solve this kind of equation also, because first you find out what is the value of x2 from this equation, first equation. So it will be in terms of x1, and then substitute that in the second equation and find out what is the value of x1 and x2. But we will be covering only for the equation which is having only one independent variable in this lecture. So taking it in graphical method, this function in graphical way, we can have a nonlinear function like this, for example, where you will be having different value of f of x corresponds to different x values, and you will be having your 0 point, that is your f of x becomes 0 at this point. That is the solution of your equation, where you will be having the value of f of x equal to 0. The corresponding x is your solution. So we will be having different values of f of x in this regime, okay, for different x values. Now in this bisection approach, we have to choose one interval within which there is a 0. For example, in this case we have to consider an interval from this point which contains this 0. So we can explain it here. If you consider this graph, this is the same graph, but let's consider this point, that is the positive value of f of x, and another point here where we will be having a negative value of f of x. So first we have to consider two x values correspondingly for you need f of x becomes positive and negative. So we need f of x equal to positive and f of x equal to negative, two values, and correspondingly we will choose two limits. Okay. So in this case we will be having limit a and b in such a way that your f of x become positive in one case and negative in the other case, and in between that these two points we will be having f of x equal to 0. Okay, that is the first condition. And then that value we have to reduce that interval. So for that we have to find out what is the average of these 2 points. In this case we have represented it by using a and b, so we have to take a plus b by 2. Okay, so then that is actually we are finding out what is the midpoint of these 2 points, and that is a plus b by 2, and we have to find out what is the function value corresponding to that midpoint. So if this function value, that is the f of x m, that is corresponding to the mid value, if it is positive, then we have to replace this a point with the corresponding midpoint. If it is negative, that is f of x m, where x m is your midpoint. If f of x m is negative, then you have to replace your b value with the x m. Okay, then you repeat this process until you have this condition, that is the absolute value of f of x is less than tolerance value. If this tolerance is if you are having 0.0001, then you check in each time, you check what is f of x m, which is less than or whether it is less than 0.0001. So we take this tolerance as 0.0001. So when this f of x m is less than 0.001, we have to terminate the process. Okay, so which means that f of x is almost equal to 0, and corresponding value of x m will be your solution. Otherwise, you can also take this condition, that is absolute value of b minus a is less than tolerance, that is your difference of these endpoints, that is b minus a. If it is very less than 0.0001, then also you can terminate the process, and the corresponding value of x of m will be your final solution. That is your solution to this equation. You will understand more in when we are doing this the example. Okay. So that's about this. We will be having a pseudocode for this method. So first we have to consider these intervals a and b. Then you have to find out f of a into f of b. So we have to check whether this f of a and f of b is less than 0. Then only we can have the both positive and negative values of the function. Suppose if you are having f of a is negative, then f of a into f of b becomes negative, or if f of b is negative, also f of a into f of b becomes negative. So in if this condition is valid, then we are having the function value which is having positive and negative at these endpoints. So we can choose a and b as your interval, because it will give you positive and negative values for your functions. Now you have to find out what is the midpoint, or you have to bisect the interval, that is x m equal to a plus b by 2, and find out what is the value of function at x m. You check whether f of x m is negative or positive, and the condition is like this. Okay, if f of x m star f of a is less than 0, then set b of b equal to x m, because when it becomes negative, you have to replace your b, that is negative boundary, with the new value x m. Else set a equal to x m, that is if f of x m into star f of a is less than which is not less than 0, which means that it is positive, then f of x m will be positive, and x m has to be replaced with a, because a was your initial positive. Then you have to break this operation by giving this condition, and when your f of x m is very which is less than 0.001, you have to break. Okay, let us consider an example for this bisection method. So for this bisection method, we are having, let's consider equation like this: f of x equal to x to the power 5 minus 4x minus 9. Now in first step what you had to do is that find out what is the value of f of 0, f of 1, f of 2, f of 3, etc., so that we will have a positive value for the f of the function, and we also need a negative value for the function. Okay. When you are having a positive value for the function and a negative value for the function, then you choose those x values where you will get these negative and positive values as your interval. So we are having f of 2 is negative in here and f of 3 is positive, hence the roots of the equation lies between 2 and 3, these are the x values, which implies a equal to 2 and b equal to 3. That is your interval. So that in between those interval your function f of x should have 0. Now you calculate the midpoint. In this case we are considering this as the first midpoint calculation. So we take it as x1. So x1 equal to a plus b by 2, which will give you 2.5, which is nothing but 5 by 2, and calculate what is the value of f of 2.5, and you can see this is negative. F of 2.5 is negative. Now you are getting f of 2.5 is negative value, which means that f of 3, okay, here you are having f of 2.5 is negative and f of 3 is positive, hence the roots lies between 2.5 and 3, because initially we assumed the negative value at x equal to 2, and we took a equal to 2 as one of the boundary point or the interval. But in this case we have found that f of 2.5 is also negative. So when your f of 2.5 is negative and f of 3 is negative, f of x will be in between. When f of x equal to 0, that will be in between 2.5 and 3. Okay. Then we have to replace this a with 2.5 and b equal to 3. Again you calculate what is the midpoint. So x2 will be equal to a plus b by 2, which is equal to 2.5 plus 3 by 2, which will give you 2.75. Now what is the f of 2.75 that you had to calculate? F of 2.75, and it will give you 0.797. So this is a positive quantity. Okay. So when it is positive, then you are having f of 2.5 as negative, right, and f of 2.75 as your positive value. So the roots lies between 2.5 and 2.75. Initially we were having the positive value of f of 3, but now you have reduced that to 2.75, because when you calculated this f of 2.75, that also give you a positive value. So we reduce the interval to 2.75. Now the roots lies between 2.5 and 2.75. So initially we considered 2 and 3 as your interval. Okay. Then you reduced 2 into 2.5. Sorry, in this case you have increased 2 to 2.5. 3 you reduced to 2.75, and in between these two values, when you substitute some x, you will get f of x equal to 0. Okay. So this value of x we had to find out, and we had to reduce this with different steps. We have to reduce again and again, and we will find out what is the value of x when the f of x become almost 0. Okay. So if you calculate this in a repeated way, then you can see the x3 value is 2.625, x4 is 2.6875, etc. up to x7 I have calculated here. And you put the condition f of xm, which is less than 0.0001. So at any of these cases, if you are getting this condition, f of xm is less than 0.00001, then you can have your solution, that is this xm will be your final solution, where you will be getting f of x almost equal to 0. Okay, so that is the bisection method. So I hope you understood this concept. Okay, so in each cases you had to substitute the value of x of 3, x of x4, x5, x6, all those values, substitute in your function f of x and calculate what is the value. And when you get that f of x value which is less than 0.00001, which means that it is almost equal to 0, that corresponding x value, that is x of 7 or x of 6, whatever it is, that will be your solution. Okay, so this is how we calculate the solution by using bisection method, where you have to first you have to take the intervals, then you reduce that interval in such a way that you are approaching towards f of x equal to 0. So we will directly go to the programming of programming corresponding to this bisection method in Python. So we already covered the theoretical part. Okay, so first we have to import numpy. So we'll give from numpy import. Okay, so this is command. So I'm writing all these commands or instructions in notepad, and I will save it in .py extension, and I run the program in command prompt. Okay, that's the method we have to use. So then we have to give the limits. Let's say a is my first limit and I am giving it as an integer value. You can also give it as a float value. So I have given this as input. That is my first limit. Okay, so enter the first limit. So that's my first limit, and I will copy this one, and I need the second limit as my b, and this is my second limit. So that's okay. I have missed one inverted comma here, so it should not be like that. Okay, that's all about the limits. Now I have to find out what is the mid value of this limit xm, which is nothing but here plus b by 2, and sorry, this is semicolon, and then I have to define the function f of x, for example. Okay, then I have to use f of x, let's say y as your function value, so which is equal to x star x, any function you can give, x star x minus 4, and I have to choose return the value of y to this function, and then I have to go for checking whether f of a into f of b, which is negative value. Okay, because we need this f of a into f of b negative, then only we can find out the roots, because in between these values we need f of x equal to 0. We have to find out what is the value of f of a and f of b now. So f of if I should write if f of a star f of b, which is less than 0, then only you can forward, because f of a into f of b should be negative. Then only you can go forward with the execution. So we have here while, let's take while absolute value of f of xm, that is midpoint. So we are calculating the function value at that midpoint, and if it is less than point, sorry, if it is greater than 0.01, 0.001, then only we can go for the next step. So then I will check if f of a into, say, star f of xm, which is positive, which means that if it is 0, then I have to replace this a with xm, a equal to xm, because you are getting a positive value for your limit, which is much more closer to 0 if you are having f of a star, f of xm is positive. And if it is not valid, which means that else I have to go for the equation a b equal to xm, and then we calculate this midpoint value again for the new a and b values. So it should be like this. Then we will print this, print the root is comma xm, and now we will go for this statement, that is for if this condition is not valid, then I had to write else I had to go for print the limits are not valid. Okay, so this is the program. So I hope you understood this program. First you have to give these limits a equal to enter these limits we have to enter, then we have to go to this statement or instruction, which is nothing but to find out the midpoint of those interval. Then we'll define this function, and we calculate whether the given interval value, which will give you a negative value by taking this product. If it is negative value, then we are having f of a or f of b is negative, which is nothing but satisfying your condition. That is then only we'll be having f of x equal to 0 in between these 2 points. Okay, then we'll go for the next step, which is the condition. Okay, we have one mistake here. So while absolute value of f of xm is greater than 0.001, then only we will check here we will check f of xm whether it is close to 0 or not. Okay, with this much of accuracy. Then we will be having the condition if f of a is star f of xm is positive, then we have to replace the positive limit with xm, or we have to replace with this negative limit with xm. Okay, so we are considering this first limit as positive and second limit as negative here. Okay, that also you can enter here. Then we'll print the root, and if this limit is not valid, then we have to print the limits are invalid. Now I have to save this file in .extension format. I don't know what it is. So this I have to save as bisection.py, and which is I have to save in users welcome. Okay, so this I had to run by using the command prompt. Then have saved, so it is already there. I think one same name, no problem. So I replaced that. Sorry. Okay, so then I have to run this by using command prompt. If you are not having any idea about how to run in command prompt, then you just search for CMD in your system. Then it will give you a black window like this. So this is command prompt. You can search in your system. Now I have to use I had to type here my file name, that is bisection. Okay, bisection.py. Then I have to run this program. So first it will show me enter the first limit. I will give you the limit is 2, and second limit, for example, I give 2, so the same limit. Then it will give me that the limit is not valid. Or if I run it again, the first limit, for example, is 0, and some second limit is 4, then the root is 2. So so the limit should be valid in such a way that f of a into f of b should be negative. Or I can give any other limits also, for example 0, sorry, this enter, so 0, and the next one is for example 2. The limit is not valid because when you substitute those values you will be getting, for example, 0 square minus 4 is minus 4, and if you take 2 square minus 4 is 0, so it is not valid, which is giving you 0 for f of a into f of b. Or I can give 0, sorry, again 0, and next limit for example 3, then it will give you one more somewhat more close value, that is 2.000 some 5 something. So that's all about the bisection method. I hope you understood this.